So the East Coast upgrade, as I might well describe elsewhere in the video if I haven't already, is like a massive series of works. A lot of these, I'll point out, were planned by British Rail through the 80s and early 90s, but anyway, lots of them are eventually coming to fruition. We've had King's Cross's, the King's Run Cross project, massive remodelling, total remodelling in fact, of the King's Cross station throat for several miles out of the station. We had turn back at Stevenage. And we had, even before that, we had other projects that are really part of this ongoing upgrade of the East Coast Main Line. If you like, it's a route modernisation by stealth. So you had, a good example is my first ever design that I opened up the design tools on, which was Hitchin flyover. So that's, in fact, showing you that right now. Hitchin flyover, which is south of here, where I am now, because it's the editing. But all these projects are all about, particularly Hitchin is an example of exactly what Werrington was all about. It's great separation of a junction. I can't remember how much Hitchin was, probably a couple of hundred million. Werrington's 250 million. So these are major capital expenditures, major projects, bold engineering schemes to essentially provide high-speed segregation. And this kind of comes back to what HS2 provides, is that even with all this high-speed segregation, each of these projects, 200 million, 250, 300, even 400 million pounds a pop. Ely North Junction is another critical one. It's not on the East Coast Main Line, but it's required to free up capacity on the East Coast Main Line, actually. And that is, wiggly, that's at least 400 million, plus a huge project. To get what HS2 provides, you need to do, every junction needs to be like this. And even then, they aren't providing the capacity release that you can achieve through total high-speed segregation. But these are miniature high-speed segregation projects, all of them, ensuring that there's different types of train not conflicting with other different types of train. In the case of Werrington, it's mostly about slow freights crossing over the path of the fast lines, as I'm going to show you in a minute, because I'm going to hop off at Peterborough on my way back north to York, and I'm going to sort of go up to the end of the platform and kind of explain what's going on, and hope we might even see a freight train on its way through. So I've come to the northern end of Peterborough. The platform's at Peterborough Station. You can see behind there. There's Peterborough Station. It's absolutely glorious, if slightly nippy, evening this Thursday. And the reason I've come up here is to sort of try and explain the problem, and with the benefit of some lovely cab footage, which hopefully I'll be getting from LNER. If not, we'll make it work. In that direction is a lot of point work. There's a lot of junction work, lots of crossovers. In fact, I'll show you. I can show you now some footage of a GBRF freight train coming out of their depot over there and crisscrossing over the fast lines to get onto these lines behind me. The lines disappearing off in the other direction, heading back onto the JNG. This is an incredibly busy freight corridor. And whilst it's not so bad that freight trains are kind of slowly coming in and out of the depot over there, because that's not happening very frequently. What was an issue before the Werrington diveunder was built was that you had this complex ladder of services, a complex ladder of junction work, point work, and you had, one or two freight trains an hour in each direction, weaving across very slowly. There's a nice local service. Weaving across very slowly over that point work and blocking the fasts for multiple minutes every hour, which is clearly a massive hit to line capacity, particularly for the freight, the fast services whizzing through, and of course a limitation on the freight, because you can't have any more of those freights because they block the fasts for so long. So what Werrington has enabled is that the freight trains come in behind me and they essentially stay off the fasts. They disappear off down through the diveunder, off onto the lines in towards Lincolnshire. Happy days. So that's what it's all about, really. And you can see that quite nicely from here. It's a nice view back towards. Werrington's only a couple of miles up in that direction, but actually, as I was saying, kind of as we were on the train earlier, the actual physical work, lots of the work, the signalling, the power, sort of all the cabling work was happening down here. Also, if I flip over here and look behind me, you can see over here that there is also behind me over here is what is like the biggest flipping signal in the country. Good grief. Ancillary civils, you're getting overexcitable. Over here you can see there's a load of S&C still sort of placed here. Peterborough points 1234, 1232 Bravo, 1233 Alpha. You can see them over there. Look, it's nice, isn't it? And indeed, so those are the switch units, and over there are the crossing panels for clearly there's junction work still to go in. In fact, when I was at Atkins, we were working on some of the junction remodelling around here. So there's lots of complicated stuff going on. Now, It'd be nice if a freight train kind of whizzed through with kind of at speed, but I've taken loads, well, not loads, I stood here for about 15 minutes and a huge amount of freight came through. So I've got some nice footage of some freight trains whizzing through, kind of showing how busy a line this is. It really is very busy. You know, this is the East Coast Main Line, and it's on, you know, this is why HS2's eastern leg was so critical, and I keep banging this drum, because the East Coast Main Line is such a heavily used freight line that relying on it to also carry all of the long distance high speed stuff is not a very good use of it's not a very good use of capacity. It's not a very good use of infrastructure to carry the most people and things that we can on the railway. Anyway, that's enough of me waffling here at Peterborough. I'm sure either I have already or will explain what actually happened, the physical work that happened at Werrington, how it all worked. Might even splice in some of my little mobile phone videos I've done when I've been passing it on the train over the last couple of years. So before we hop in the cab for our return journey through the Werrington diveunder, I thought I'd drag us kicking and screaming south to Hitchin, back to Hitchin again. Back to my first time on the tools. You might be wondering why I was on the tools when the project was starting before I joined the industry kind of full time. Well, it's because actually I was jumping on the tools after it had been built to do some as-built kind of fettling. It's a long story. Anyway, Hitchin. So you can see here, Hitchin. Here's the Hitchin, and it's the same sort of story as up at Peterborough. You've got the station. You've got a big, complicated sort of load of junction work with trains having to kind of make their way across, sort of like that, and then disappear off. So the freight trains kind of doing that, and likewise, same in the opposite direction, and that basically means it's stopping the fast trains. The fast trains are having to kind of be held at signals to allow this to happen, and it's blocking the lines for lots and lots of minutes. So what do they do? Well, as you can see, the jump forwards to March 2012, and you can see a load of nice kind of groundwork here. In fact, going right the way down, you see there's a load of kind of excavation work, probably collecting soil. I dare say there's some borrow pits and stuff, generally just to sort of provide the earth to actually raise the land here, because rather than going underneath, they went over the top. So jump forwards again to August 2013, and you can see pretty much, I think, the work was finished by that point. I picked up the design about a year later, so maybe this is still just ballast and they haven't put the track down. In any case, you can sort of pretty much see the line. It's much more of an open, whereas Werrington is much closer to the existing alignment. There was more space and the geology was more favourable, so they could have this slightly more wide sweeping sort of flyover shape. There it is, going like that. Very nice. So then, if we hop forward to 2016, it's well and truly established, and you can sort of see what's happening. So rather than getting snarled up in the junction work here, the freight trains, going in whichever direction they're going, they stay away from the fast. They don't spoil, get in with the way the fast trains. The passenger services, they whiz over the top of the East Coast Main Line, climbing up over the flyover, and then come on down and rejoin the SBR lines towards Cambridge, to just get snarled up at Shepperth Branch Junction, which thankfully will be getting fixed, and then definitely snarled up at Ely North Junction. But this is the way that when you solve a bottleneck, what you do is you result in the next bottleneck becoming the problem. But anyway, you can see here what's happening. Thanks to there being a nice sort of bridge over the East Coast Main Line there, and that was really the difference at Hitchin rather than at. So here's the flyover. The tracks leading to the flyover. The flyover actually starts from here to about here, I think. So that whole structure it's a pretty unique bit of civil engineering, but that's another story. That's the flyover itself, and then those are the lines. Anyway, the whole point of that is exactly the same at Werrington. It's a grade separation, except that rather than at Werrington where it was a dive under, in this case it's a flyover. Yeah, there it is, looking quite spectacular. It's nice structure. And as engineers, we go through a lot of work to decide, optioneering between, right, is it going to go over, is it going to go under, what are the pressures? At Hitchin, they didn't have the Stamford lines, which meant there was a narrow formation, but they also didn't have lines to divert round. So, the different pressures, different, the environmental issues, the residents, where their properties, all these things influence whether we go up or whether we go down.